Okay, so let's do a slightly different case. It's still the same base. I'm gonna put a little twist to it so that you have to do a little bit of work to show that it's actually the same base. Okay, so here's an example. Okay, shouldn't we do that? Okay, so how about that? Is the base same? It's almost the same. It looks a little bit different. So in math, if it looks a little bit different, do not assume it is the same, okay? So there is actually a special relationship between a minus b and b minus a. B minus a, if you just multiply this by -1 and expand, you actually end up getting a minus b, okay? So this is equal to this. Now this makes sense if you try with some few real numbers. 4 minus 2, 2 minus 4, this is positive 2, this is negative 2. So if you multiply the negative 2 by a negative, you get the same thing as a positive 2. So that's what we want to use here. Okay, continue down here, you get x minus 1. And you just multiply top and bottom by -1. So if you multiply this by -1 and this by -1, we end up getting a -3. On the bottom, we get x minus 1. Okay, positive x minus 1. Now it's exactly the same. Okay, so we get 1 minus 3 over x minus 1. Done. Okay, let's do one more. Okay, let's say you have 2x minus 5 negative 5 over 5 minus 2x. Again, notice I just switched. Okay. So we can multiply top and bottom by -1 again. So you get a -5 over 2x minus 5. Okay, now the base is the same. Note that these two negatives we can simplify. 2, 4, right? Like so. Now it's exactly the same, so we can add it just like before. Okay, so that is still essentially the same denominator, equal denominator, but you know, there's a slight negative factor and how to deal with that. All right, that's it for this one. I'll see you in the next.